Hello, everybody. So today's the last class, our last day of class for SCD3. Do not forget, Sneaky Sneaky is due today. So make sure you are wrapping things up for that. Hopefully you've started it by now for sure. Not too much time to do all the stuff that's required for it. But today we'll be mainly focusing on the very last thing, which is going to take a look at how we can go further with specifically Unreal AI. This class has mostly focused on just the state machine topic and seeing how that can be implemented. And it is commonly used for general game development stuff across everything, like the state machine or the animations use a state machine. It's used for just super common pattern that understanding that programming pattern will really help you out with general programming. But Unreal itself does have some built-in AI stuff. And so this last assignment, that should say 50%. Actually, let me fix that real quick while I'm right here. Might as well. It says it in the other document, just not there. One moment. Sorry for the delay. %. So your very last assignment for the course will be, let me publish that again. Back to enabled, and just go back. In class. I got stuck in a loop. Oh, good. My internet having fun today. There we go. Oh, of course, I'll try and refresh right after. And there's a message saying it's unstable. Fantastic. But so this very last assignment, preview that, not grade it. You will have to complete one of the courses on Unreal things or Unreal Learning, just 50% of the course. There's instructions in this document, kind of describing where to find the lesson, and your submission for this will be a screenshot showing that you've completed at least 50%. And make sure it does show your username. If your username isn't something like your name or anything, make sure to just go to the account page and take a picture showing your name with the username as well. All right. So this will be digging into the specific Unreal tools for the AI stuff. We already saw a little bit about that with the perception thing that we were playing with earlier. But let's take a look further along outside of these materials and just kind of see what kind of topics they'll be introducing. In addition to that, I do have this link here in this assignment to direct you to a YouTube channel. One of my favorite YouTube channels is Rylan Laley. He's a games instructor over in the UK, and he has some great tutorials for Unreal specific stuff, not just AI things, but there's a lot of really good like playlists and stuff he's put together and is constantly releasing new things multiple times per week for general AI, general Unreal stuff. So I definitely recommend giving that a save and checking out his channel, because it's been a lot of the same kind of things we're teaching in more bite-sized little pieces, and could be specific for what you're trying to go for in external projects outside of Full Sail. All right. So as I mentioned, we'll be digging into a little bit, kind of just taking a brief look at the behavior tree system built into Unreal, which is another way of controlling behaviors of NPCs or things like that. So we have this sneaky project that we were just demoing how to get some different states and stuff set up similar to the sneaky project you'll have to implement. And we'll go ahead and build that, take a look at how we could use behavior trees instead of just a state machine for this. What I'm going to do is create a new folder here for all the behavior tree content. We'll just call it BT for behavior tree. Don't need it in the content, or don't need it in the state machine folder. Move it to just content. And I will create a new level for this as well, just so we can start fresh. BT demo, and oh, that's going to be a blank level, isn't it? If we open that up, yeah, sure, save it. Blank level, fantastic. Let's go to the more advanced new level option to get a default map going. Get rid of this one. And just save the default map so we have a little bit of an area and lighting and stuff all laid out for us. In BT, this will be our BT level. All right, first thing I'm going to do is make my floor a lot bigger so we have a little bit more area to run around in. Once my computer stops being weird today, let's just multiply x by 5, y by 5. And you'll notice that if we're modifying something marked as static, it has to bake the lighting. So it does give you this warning, lighting needs to be rebuilt. Static lighting is a more efficient way of fastest rendering. So it's going to be the quickest and most efficient. You could just change anything that you don't want to have to rebake to movable, and it's going to use the dynamic lighting. You really only have to worry about optimization once you start getting into a bottleneck and stuff like that. So I wouldn't worry about it too much. It's not much more expensive to do the dynamic lighting, especially on a flat surface like this with a simple shader. So we'll save that. And if we just play straight away, we have the fly camera and stuff. Not what I want. I want a player character in here. So for this level, I'm going to go to the world settings. You can open that tab through here and it should open the tab up next to details. We'll go for that top-down game mode that we had before, or that we added before rather. So we do have the point and click to move. Obviously nothing's moving because in order to navigate to something, it has to have a navigation mesh. So we will need to add nav mesh bounds volume to here. Just drop it in the center of our level and scale it up. Let's go 30 for each. And make sure that it is containing all the level. Quite a bit taller than I really need, but that's totally fine. As long as it is containing the level. We click the floor, press P, we'll see that nav mesh. Turn off P so the green doesn't burn our eyes. And save everything. If we play now, point and click, got our basic character in here, player character rather. All right, next thing I want to do is make an AI character using a behavior tree versus the state machine stuff that we have been. So I'm going to create a brand new character here. It will be a character, so it has all the pawn stuff can be controlled by a controller as well as the ability to walk around, so it has that movement component for us. We'll go ahead and call this NPC underscore BT for behavior tree. We'll open this up and make sure that it has a mesh so we can see it in game. We'll just go with let's go with a female mesh since our other character is the male. Drop that down, -90. Rotate it about the upward axis, -90. Computer's having a little bit of a hitch every once in a while. Interesting. So it's facing forward. And then we've got a character. Let's drop one of these into the level. And we'll also make sure that it has the animation blueprint on it. So our mesh, we can just reuse that same animation blueprint that we have. Oh, don't collapse that. Use an animation blueprint. Which animation blueprints? Well, we have a third person AnimBP set up that does the idle, walking and running and stuff all for us. All right. So we've got this in here. Now, I keep mentioning behavior trees, but we haven't created one yet. So we'll go ahead and create one now. I'll right click under artificial intelligence. A few different options, behavior tree. Behavior tree goes one-on-one with a blackboard. We'll talk about that more in a moment. And there's also something called environment query. We won't cover that in this course, but I believe the Unreal tutorial, as well as some of the Ryan Laley tutorials, also go over that, and it's super awesome to figure out like where's the closest thing. If I wanted to get like hide behind cover and stuff, that is a very awesome tool. But we're going to start off with just a basic behavior tree. Let's give this tree a name. One of the most common behaviors to get a basic NPC doing is just wandering around. So we'll do that first. We'll say BT for behavior tree underscore wander. All right. So when we double click this, it's a new interface. So behavior trees are kind of a more visual way beyond visual scripting to choose a specific behavior and lay out the logic of how it's going to choose one behavior or do one thing versus another. So we'll just save this for now. There's an option to create a new blackboard. Right now, it has to have some sort of blackboard assigned to it if we want to have our controller or character talk back and forth and be able to pass data to this behavior tree. So let's just go ahead and create a new blackboard as well. We'll just name it the same thing, BB Wander. Well, not the same thing, but rather changing that initial part right at the beginning. So this will be BB for blackboard underscore wander. So we have a blackboard and behavior tree for wandering. I'm going to go and make sure that my behavior tree is set to use the wander blackboard. We'll save that. And the behavior tree, we're given one root node. This is where everything starts from. From the root, we can drag off and place a new node. A few different options we have here: selector, a sequence, and a simple parallel. These work in different ways. If we take a look at the sequence, it's going to basically just go from the left to right, whatever's connected to it, execute that node. When it succeeds, goes to the next one, execute that node. When it succeeds, go to the next one, and so on. If it fails, then it fails out of the entire sequence and would restart it over if it just continues on this path. If we take a look at a selector node, selector works kind of differently from that. Selector node goes from left to right, which sounds similar, but it actually will only go to the right if the first one fails. So we'll see that in action in a little bit. We're going to start off with just a simple sequence. For a wander sequence, we need to know where are we going to like move to? Like we have to find some location that's kind of around a certain radius for our character. So each one of these we can add in. There's a few different general tasks. We have, if we look under tasks, there's many different things we can do: make noise, play a specific animation, play a sound. So just some general things all set up for us, even move to. similar to that function call we use to get our NPCs moving around. We just say, hey, simple move to, and tell it where to move. So we will want it to move. However, move to, it's going to need to know where to move to. Like right now, we see it's set to a Blackboard key automatically, and it's going to move to itself. That is the only Blackboard key we have. If we already have the Blackboard assigned and we're in this view, one of those things I mentioned was behavior trees go hand in hand with the Blackboard. You can use this to hop back and forth between the two. Just like if you're in a widget, you have the designer view and then the event graph view, things like that. So our Blackboard, it came with one key called self actor. That's a reference to the actor itself. So that can come in handy, and they just automatically include that for you. We can add another key, and this other key can be any type of thing we want. There's the basic types right here. We could even just say it's a basic object and give it some other stuff. We'll be looking at that in a moment, but we just want a position. So a vector would be great for holding a position. We want to know where will we be moving to, or a destination. We'll set this up and just call it destination. Save that. And rather than moving to itself, because, well, the actor's already there, we'll tell it to move to a destination. The other part we'll need is we need to tell it a value for this. Now, you're not allowed to set Blackboard values or anything like that to a default value. We see like no option to actually type in the 3 floats for a position or anything like that here. So what we'll need to do is create a task to find a random location. So in addition to just the normal tasks that are built in, we can actually create a new task right up here using one of these, just this button. Create a new task. It created a task for us. We'll take a look at this in a moment. And a few different things. We can override 6 overrides available. What to do if it was aborting this task, if it was aborting the task AI, receive execute. So basically what that is when this task is running, similar to our state tick or things like that. There is even a tick as well, but let's go for receive execute. When we tell this task to start running, and it'll start running this code. So we mentioned that we want to get the Blackboard and stuff. We just right click and say get Blackboard. We can get that straight from here. It does need a target for which actor would have this Blackboard. Well, that's where this owner target actor comes in. So for the specific NPC, we'll get the Blackboard for that one, and then we'll be able to set a value for any of the keys that we have set up. We have to make sure that we're using the correct type. We created a vector key. You have to tell it a key name. So we'll just make literal string or make literal name and type in what we named that key. I called it destination. And as a start, we'll just have it set it to 0, 0, 0. And now we might as well do the random. So there's a random option. If we just right click and type in random, there's a whole lot of different random functions for you to use. Just getting a random thing. I'm going to say random location in navigable radius. So this will actually take in an origin, a specific radius around that position, have an option to feed it some specific data or filter between different navigation stuff, and we'll spit out a random location based around that. So we'll make sure that the origin is just wherever our actor is in the world. Get actor location. That's our origin. As far as the radius goes, I'm going to go ahead and promote that to a variable so I can set it in the actual behavior tree itself. So we've got this variable. Let me straighten this out a little bit. Nav data, if you don't plug anything in, it just uses the default stuff. Same goes with filter. We don't have any advanced navigation stuff, so we're just using the basics. Don't need to pass anything in there. For this radius variable, I do want to be able to change this value per instance. And we'll also make sure that it's not a radius of 0. That would still just be that actor's location. So we'll start out with a radius of, let's say, 3 meters or 300 centimeters. All right, and then that'll go over to the blackboard, make a mark on it for the destination key. So our behavior tree, if we want to use that task, and this was, I didn't rename the task. I just kind of clicked that new task. The new task came with this name, BTG task blueprint base. That is not very descriptive. What this is doing is just finding a random location and setting the destination. So we're going to rename this blueprint. Let me just save it right here first. And find that in our browser. So it just created it right next to the behavior tree that we had created. Let's rename it BTT for behavior tree task. Find random destination. All right. So if we go ahead and just play this game right now, our character won't know anything about this behavior tree. We haven't told this behavior tree to run. I also forgot to add that task that we created here. I wanted to rename it and I just renamed it, but forgot to add it after the rename. So I called it BTT find random destination. And we see since we made a variable in that task and made it public, we can change that destination right here. Really nice for tweaking values and stuff in the tree without having to edit hard-coded things over in the task itself. All right. Next up, we need to tell our NPC to use this wander behavior. So the controller that'll get assigned to this by default and what's controlling it in general is way down towards the bottom under, there it is. So it's going to be auto-possessed by an AI when it's placed in the world. The specific controller class that it's using is just the default AI controller that's built into Unreal. So we could create our own controller and have that start a certain behavior tree, but let's do it a little bit of a simpler way without having to add any more files that just tell it to do stuff. Right on begin play for this character, I'm going to get AI controller for this actor. And that spits out that AI controller reference. And I'm going to just say run behavior tree. Run behavior tree allows us to select which behavior tree we want to run. Well, let's just go for the wander. Compile, save. And now our character should try and run this. It'll spit out a bool whether it succeeded or not. If we just play, our character's sitting there, not doing anything. If we bring up our AI debugging, we see it's no longer that red face that we saw earlier. It's now kind of a goofy green face. That means that it is running a behavior tree. We also get more info on this than we did before. It's actually running a behavior tree component. It's running that BT wander sequence. If we have this still running and check out our behavior tree, we'll see which node it's actually executing at the same time. So it's sitting there, constantly running this find random destination. We hop over here again. We're also able to see any of the Blackboard values. We have that Blackboard right here. Its current destination is 688, and blah, blah, blah. So it tried to find a random position around here and then never moved on to the next thing in the sequence. So the way the sequence works, it has to wait for this task to finish or say it is done executing. Right now, if we just double click that, it'll open the task up for us. It's just setting this vector and then doing nothing. We have to report back saying the task is finished. So there is task. It's not finished. I'm trying to think of the proper name for it. Finish execute. That's what it is. Finish executing. And we have the option to say whether it was successfully finished, or like if you have a complex task that's looking for a specific character within a range, you could tell it, no, it didn't succeed. So a selector could switch over to another one. But for our purposes, we're just getting a random point and setting that value. Suppose ideally we could say the task can fail technically if it fails to find a location. Highly unlikely with just a simple setup like this, but we could pop that over. And now, if we go ahead and play, we'll see our wander guys freaking out. He's constantly finding a random destination, moving to that destination, then cycling back over for the sequence. You generally don't want AI to respond immediately as soon as it finishes an action. So you'll generally want to add some sort of wait. And there's a built-in task to wait a specific amount of time. So after it finds a random place, moves to that place, then we'll wait maybe, let's go 3 seconds. There's also something called random deviation, so it's not always just straight waiting the full 3 seconds. We could say it could end maybe half a second early or half a second late with a random deviation of 0.5. So plus or minus 0.5 seconds. So we play, wandered to that first position, waited a little bit, and and I just placed one of the distract points. Doesn't matter right now since our AI is not detecting anything. But we'll be able to see that NPC. We'll see this destination actually update as it's cycling through the different things, and it'll even show specifically which node it's going through and sitting on that wait time, how much time's remaining for that, things like that. A lot of really good built-in details for seeing how that AI is functioning. rather than have us having to add a whole bunch of print strings like we did for the state machine. So we've got this moving around and stuff. We also have our player character that can run around. Let's say we wanted to step this up a little bit and see how we could create a follow state or follow behavior if it does detect our player. All right. So on the NPC, we'll go ahead and add some perception for it. We'll add that AI perception. Set up the senses real quick. Senses sight, dominant for sight. And before I forget, I'm going to change that detection by affiliation, since by default everything is neutral or friendly. Can't remember which one it is, but those have to be checked. How big of a radius? 3,000 is quite big. Maybe 10 meters, just 1,000. And 1,500 for the lose sight. 90, yeah, we'll just leave it 90. So anything in front, maybe 76. Why not? All right. So our AI perception is set up there. Our player controller already has the stimulus source all set up on it. We just need to have our NPC respond. So we'll right click, add an event for when the target perception is updated. So when the AI perception is updated, spits back that character or the actor that it detected, as well as the stimulus stuff. We'll break that apart. So we can get that whether it was successfully sensed or not. Need that for branching, whether it does see it or it lost sight of it. We'll go ahead and make sure that this other actor, we had that same tag. So we'll look for the player tag. Actor has tag. Just to be nice and thorough with this. If it does see the player, branch. If it doesn't see or if it sees something else that's not tagged with player, for right now we'll just ignore it. If it is the player and it did successfully sense and we want our behavior tree to react to it, we're going to need to add a Blackboard key to be able to talk to our behavior tree. So I know we have just this wander behavior running right here. Let's go ahead and bump this up, even though it is called wander. Usually not a fan of doing it in something that's called wander, but we'll just do it right here for ease of use. We'll go ahead and say not only does it have a destination, but we'll add another key. Now you'll notice that there is no actor or anything like we would normally give a reference to that, but there is something called object. Object is the very base type in Unreal. Even though actor is the base type that could be placed into a level and stuff, object, everything is an object. So this object key will actually call target enemy. And with an object type, you can tell it specifically which type over here. We can expand that and select any specific class. We'll just go for a basic actor, and that's now got an actor key that can be set. All right. Then our behavior tree, I kind of want it to react. It'll run this sequence, but if it spots a player, I would want to have some sort of other sequence where it'll start moving to the player. if I just try and pull off this and create another sequence, you can't have multiple sequences like that. So we will use a selector to figure out which sequence we're going to be running. Selector. We'll have it run this sequence. But if this fails, we'll then run this player sequence. And what this is allowing us to do is on each one of the sequence nodes, we can actually add what is called a decorator. Decorator is a way of like, I want a condition on this sequence. I don't want this sequence running if we have a target enemy set or something like that. So we'll add a decorator specifically for a Blackboard value. Blackboard base condition. We'll be asking if it is not set. We'll have this run it. The Blackboard key is going to be for the target enemy. So whenever that's set, or when it's not set, we'll run this. If it is set, would run this. And up here we have the ability of when it's going to actually kick out of this sequence or things like that. So when the target enemy does get set or changes from not set to is set, we're going to tell it to abort. The lower priority, so any of these bottom tasks as well as self will do both. So kick out of this if any of that's done. All right. And then it'll run the sequence. We'll just say this would be when it does see the player. We'll add a simple move to task. Move to, where do we want to move? Towards target enemy. Okay. Now we still need to deal with setting this Blackboard key. I had just created it and started using it in here, but we have to give it that value back in our character. We never finish this part when it does detect the player. If it successfully detects the player, we'll go ahead and set that Blackboard key. So we'll have to get AI controller, self, and I'm curious if I just type like get Blackboard from here. Oh, I can get Blackboard straight from self. I'm curious now if that comes with. So I guess that's just part of a pawn that's built in. Nice, that's a little bit cleaner. Still need that self node, pass in which actor we're dealing with. That'll give us a reference to that Blackboard. We can then set that value. Set value as an object. When that's true, which key name are we doing? Going to double check that key name here. Called it target enemy, capital T, capital E. Watch out for any leading or trailing spaces. Just make a literal name here and type that in. Target enemy. And enemy. And then what value are we going to set this to? Well, that'd be the actor over here that it detected. We can go like that, and obviously that's not very clean. So I'm going to double click and create a couple reroute nodes just to make it a little bit cleaner on getting over there. All right. File save. And if this is false, I would also want to set or clear out that target enemy. So when it loses sight of the player, I'm going to make sure we're doing same thing for the blackboard, but rather than setting it to a specific value or have an input pin plugged in, it will just be setting it to nothing or have nothing passed in. So it clears that variable out. Okay, here we go. So I'm going to pull up our AI debugging. I'm going to also press 4 on the numpad so it does have that perception showing. And as we can see, it spotted me when it turned around and randomly wandered towards us. And our characters are moving the same speed. Let's tweak that a little bit. Select our NPC here. Just slow him down a little bit so we can get away from it. And for walking, max walk speed, half the speed of the player. If we're playing, it's just randomly wandering around. I'll pull up my AI debugging. So the AI wasn't really on screen when I first pulled that up, so it's not showing me that specific character. So I'll just shut that off and turn it on when it is on screen. Turn on that AI again. And we'll see if I can get away from it. Have to reach that purple bound and just lost sight. It is now switched back to just running wander. It's doing the sequence where it just moves to that random position. I'm able to even enter this pink radius because that's only after it saw me. It'll only lose track after that time. So it doesn't immediately respond if you're like right on the border, enter and exit. So it does have to detect you, and then will keep detecting you until you go outside that extra radius. All righty. So that was just another brief look at this. The Unreal stuff, we'll go into it a little bit more, as well as especially if you check out the Ryan Laley tutorials for some more advanced AI. It is just another way of laying out how it's choosing what to do at that certain time. So any questions about any of that I showed today?
I don't have any questions.
All righty. And Sean, welcome. Did you have any questions about any of the basic behavior tree stuff?
I don't think I've got anything today.
Well, okay. Then I guess that was a pretty short one.
Love that behavior tree stuff, though. It's real fun.
It can get there's kind of complicated at first because there's a lot of different files you have to start adding and working with and stuff. So highly recommend if you are doing it, be very clear with the naming conventions and stuff. So like Blackboard, I always do BB, behavior tree, always initialize BT, because as you add more and more to the game, you need to be able to quickly figure out which thing goes with what and what is it actually doing in that asset versus just a generic name like behavior 1, behavior 2, or anything like that.
Yeah, one thing that Ryan Laley tutorials was really good at and was like about this, every time you made a new behavior, it like doesn't, you have to go back and rename it. You can't just type it in right away.
Yeah, as
So
soon
it's
as
easy
you
to
do like a
have.
new task or behavior tree, just those buttons are super convenient up here, but first thing you should do, rename it to what its purpose is.
Yeah, before, because
Yep.
then if you get a couple, you're instantly, wait, what is this one?
Alrighty. Well, thanks for joining, and I'll go ahead and stop it here.